Hey everyone, welcome back to Window Seat Studies. I hope you all are doing well. So we are continuing our series of histone modifications, and in that series we have already learned about histone acetylation, which is a universal active mark, and histone methylation. It happens on lysine as well as arginine residue, and this methylation mark could be either repressive or active depending on which lysine residue or arginine residue it has been added. Okay, so it has a lot of factors in it for deciding whether it is going to do the repression or it is going to do the activation of the gene. So we have learned about the H3K9 methylation mark in previous lectures in detail. Okay, so today we will learn about other methylation marks such as H3K27 methylation mark, H3K20 methylation, H3K4 methylation, and the last but not the least, H3K36 methylation mark. So we are going to learn about all those in detail. So H3K9 methylation mark is a repressive mark. We have already learned that. Just like H3K9 methylation mark, H3K27 methylation mark is also a repressive mark. Okay. So this H3K9 methylation mark was the hallmark of heterochromatinization, right? Okay. Well, the H3K27 mark is a hallmark, or it is related to the silencing of the gene by PRC complex, polycomb repressive complex. I'm sorry. So this PRC complex is a complex which is comprised of the polycomb group of proteins. Okay, PCG. So this complex has polycomb group of proteins. Okay, and those proteins are the one which are going to repress the gene. So okay, so in this complex there's a enzymatic domain which is known as EZH1 or 2. So specifically here it is EZH2, which is going to do the K27 methylation. Okay, H3K27 methylation. Okay, so this is the enhancer of zest. This is the full form of it. Enhancer of zest2, EZH2. This is the catalytic domain or the enzymatic domain which is going to methylate the H3 protein at 27th lysine residue. So this is the catalytic domain of the PRC2 complex, which is going to do the H3K27 methylation. So that is why this is the we say that this is the writer enzyme. Okay, so this is a subunit, this is a subunit of PRC2 complex, PRC complex. Okay, so this subunit is going to do this is going to do the methylation of the 27 lysine residue. So this is and this that is why this silences the gene, this PRC2 polycomb repressive complex. So in the name you can see it's repressive complex, so it is going to do the gene silencing. We will learn about the mechanism by which it does it in detail in other videos. For now, the main thing of focus is that the EZH2 domain, this is the enzymatic domain which is going to add this mark. Okay. So the other mark, the H3K20 methylation, this is also a repressive mark. Okay, and this methylation is done by SUV20H1 or SUV20H2 enzymes. Okay, and this methylation mark is important. Why? Because it silences transposable elements. So it is important for maintaining the genomic stability, because it is going to silent the transposable elements, the jumping genes, and that is why this is a repressive mark. Okay, The fourth mark that we will discuss is H3K4 methylation mark. So all of those three which you learned till now were repressive mark, but H3K4 methylation mark is the active mark. Okay, this methylation mark is active mark. This is very important. Okay, you should never forget it, that H3K4 methylation mark is an active mark. So this okay, so just one thing to be clear, that all of those methylation marks, this could be monomethylation, dimethylation or trimethylation, but each of those has different function. For example, H3K4 or K9 methylation differs, the functioning or the consequence of this mark is different than H3K9 dimethylation mark and different from the H3K9 trimethylation mark. So one thing to note is that in all of those marks I am discussing about the trimethylation. Okay, so all of those I'm discussing about trimethylation. Okay, so do not forget this is very important, that we are discussing trimethylation of those. Okay, because in the H3K4 methylation mark, the dimethylation or the monomethylation, it just poisons the gene. So imagine there's a race, okay, and all of the athletes, they have taken their position, so they just need the signal, get set, ready and go, and they'll start running. So the position in which the athletes are, like they are ready to run but they are not running, that is what we call the poised state of genes. Okay, that is what we call poised state. So the monomethylation or dimethylation, it maintains the poised state, but the trimethylation, it activates the gene, and that is why it is the active mark. So just the thing to note, the take home message is that we are discussing trimethylation in all of those methylation marks. Okay, so the H3K4 methylation is the active mark, and this is set by the enzymes. This is set by the enzymes in the complex of set or MLL complex. Okay, so this is a complex which has different subunits like set 1A, set 1B, MLL from 1, 2, 3 to 4. So this complex has different subunits. Okay, and those subunits has set domain. Okay, the catalytic domain is the set domain. Okay, that is the important thing to remember. And this by the set or MLL complex, the H3K4 methylation mark is added at the transcription start sites. Okay, so at the transcription start site, this mark is added, and it denotes the activation of gene. So obviously you will need the active mark at the point where the activation of gene is needed, right? And that is why it is done at the transcription start site. Here you can see the here you can see the methylation mark, which are repressive mark. They are either done on the centromeric region, okay, or the telomeric region, the regions which are heterochromatin, okay, or they are done at the transposable elements. So all of those are done at the regions which are heterochromatinized, okay, which need to be silenced. While the where do you need the transcription? At the start site, at the gene, right? So it is always done around enhancers or the transcription start sites. Okay, so H3K4 just like the H3K4 methylation, H3K36 methylation mark is also an active mark. Okay, so we are not going to go in detail for the K36 methylation mark now, but the important thing that you have to remember about this mark, what is the difference between both of this, is that this K36 methylation mark is hallmark, or it is very crucial in transcription elongation. Okay, this is a very important and very distinct thing, right? Okay, why? Because all of those are either repressive mark or active mark. So like H3K4 methylation mark denotes the activation of gene, but H3K36 methylation denotes the transcription elongation. So this is a very important point that you have to note, that it denotes the transcription elongation. So this is done. So where do you need So from the purpose, like it is required for transcription elongation, you can obviously guess the site of the of this mark. What would be the site? Pause the video, think about it. So the site of the methylation for the 36 methylation on the H3 protein, it has the purpose of elongation, right? So it should be done as the 3' end of the transcribing genes. Okay, why? Because the transcription goes from 5' to 3'. So if you want to elongate the transcription, it should be done at the 3' end of the transcribing genes. Okay, I use this short form for transcription. So at the the 3' end of the transcribing genes. So these are the all of the important points that you have to memorize, or you have to take a note of in all of those different methylation marks. So just to summarize, H3K9 methylation. Okay, just to summarize, H3K9 methylation, K27 and K20 methylation, all of these are repressive marks, while H3K4 methylation as well as H3K36 methylation, those are active marks. But a very distinct feature is that H3K36 methylation is involved in transcription elongation, while H3K4 methylation, as it is an active mark, it is done at the transcription start sites. Okay, so yeah, the H3K9 methylation mark is hallmark of heterochromatinization. So, and it recruits the HP1 protein, while the H3K27 methylation, it is the hallmark of the gene silencing by PRC complex. Okay, H3K27 methylation is also a repressive mark. It is done by SUV20H1 or SUV20H2 enzymes. So this is it for today. I'm not I have almost covered all of the important methylation marks in this lecture. So yeah, so this is it for today. But in the tomorrow's lecture, we haven't yet learned about the enzymes. So like I just told you the writer enzymes, the name of the enzymes, like SUV, here the K9 methylation is done by SUV39H1. Okay, so and this the H3K20 methylation is done by SUV20H1. The H3K methylation is done by SET or MLL complex, while H3K36 methylation, this is done by SET D1 complex, so SET D1 enzyme. So you don't really need to memorize this one, but it's just for info. So these enzymes, we have to discuss those in detail. So we will discuss about those enzymes in detail in the next lecture, as well as we will also discuss the demethylases. So these are the HKMTs, right? The histone lysine methyl transferases. So we will also discuss about the histone demethylases. Okay, what is the catalytic domain of those enzymes, so how do they function, all of those things, and which enzyme adds which mark, we have already covered that in this lecture. So that's it for today, and after discussing those enzymes, we will also discuss about the arginine methylation, right? So you know that the methylation on the histone is done on the lysine residue as well as arginine residue. So till now we have been learning about only the lysine residue methylation. So we will also learn about the arginine methylation. Okay, so that's it for today. I hope you will continue. I hope you're enjoying this series. So that's it for today, and I'll see you. Bye bye.